In the narrow, fog-draped streets of early 19th century London, where the hum of carriages mixed with the chatter of vendors, a young boy walked barefoot to work, his hands stained with ink and glue. His name was Michael Faraday, born in 1791 to a poor blacksmith's family in Newington Butts, a small village that would one day become part of London. At that time, London was a city of extremes, wealth and poverty living side by side, invention and ignorance hand in hand. Faraday's world was one where education was a luxury reserved for the privileged, and curiosity was a treasure few could afford to follow. Yet, in that modest boy's heart burned a light brighter than any lamp of his age, the light of wonder. Faraday's family struggled daily to survive. His father, James Faraday, was a hard-working blacksmith who often fell ill, and his mother, Margaret, was a woman of great strength who managed the home with patience and dignity despite poverty's constant presence. Michael had little formal education. He attended a local day school only until he was 13. Beyond that, life demanded that he work to help his family. There were no universities, no laboratories, and no wealthy patrons waiting for him, only the raw streets of London and his restless curiosity. Yet that curiosity would become the instrument through which he would reshape the world. When Michael began working as an apprentice to a bookbinder named George Rebow, his life took a quiet but extraordinary turn. The small bookshop on Blandford Street was a world of its own. Walls lined with books, the smell of paper and leather filling the air, and endless shelves holding the knowledge of generations. Most apprentices saw the books merely as merchandise, but for Faraday, they were gateways into new universes. As he carefully bound each volume, his mind devoured their contents. He read everything he could lay his hands on, from chemistry and physics to philosophy and art. Books became his teachers, their pages his classrooms, and their words the sparks that ignited his imagination. Among those books was Conversations on Chemistry by Jane Marcet, a work that would profoundly change his life. Written in a simple, conversational style, Marcet's book explained the mysterious world of chemistry to common readers. Faraday, with his limited education, could understand it easily, and it filled him with awe. He began to replicate the experiments described in the book using makeshift tools and materials he could find or borrow. Bottles, wires, magnets, and candles became his laboratory instruments, and the small room above the bookshop turned into his first lab. It was there that the young apprentice first began to grasp the invisible laws that governed nature. The same laws that would one day lead him to the discovery of electromagnetic induction. Faraday's thirst for knowledge was relentless. He was not content merely to read. He wanted to see, to touch, and to understand. Every spark, every chemical reaction fascinated him. He began attending public lectures whenever he could, though he could barely afford the tickets. His chance to witness true scientific greatness came in 1812, when he attended 4 lectures at the Royal Institution given by Sir Humphry Davy, one of the most famous scientists of the age. Davy was a charismatic speaker, known for his dazzling experiments and poetic approach to science. Faraday sat among the audience, captivated, watching as gases hissed, flames danced, and ideas seemed to materialize in the air. He took meticulous notes, sketching the apparatus and recording every word he could. For him, it was not just science, it was revelation. After the lectures, Faraday bound his notes into a neat volume and sent it to Davy, along with a letter expressing his admiration and a humble request for employment. It was a bold move, one born not of arrogance but of desperate hope. Davy was impressed by the young man's enthusiasm and precision, but there were no immediate openings. However, fate intervened. A few months later, one of Davy's assistants was dismissed after an altercation, and Davy, remembering the eager bookbinder, offered Faraday the position. It was a moment that would change history. When Faraday entered the Royal Institution as Davy's assistant, he stepped into a world that must have seemed like paradise. The laboratories were filled with mysterious apparatus, glass tubes, wires, chemicals, and strange machines. For the first time, He could work alongside some of the greatest minds in Britain. Yet his early days were far from glamorous. He was often treated as a servant rather than a colleague, cleaning bottles, preparing experiments, and carrying equipment. Davy's wife, Lady Jane Davy, reportedly treated him with disdain, considering him socially inferior. But Faraday endured every humiliation silently, his eyes always fixed on the experiments, his mind absorbing everything around him. He knew that true learning required humility. Through persistence and observation, Faraday became more than an assistant. He became a thinker in his own right. He learned from Davy's brilliance, but he also saw Davy's flaws, his pride, his impatience, and his growing jealousy as Faraday's talent began to shine. But none of that mattered to Michael. What mattered was the science itself, the beauty of discovering nature's secrets. In those quiet moments between experiments, he would jot down his own thoughts and ideas, trying to connect the dots between electricity, magnetism, and motion. He was building, piece by piece, the foundation for discoveries that even Davy could not foresee. What made Faraday extraordinary was not just intelligence, but imagination, a kind of scientific vision that allowed him to see patterns where others saw chaos. He was deeply influenced by the idea that nature was unified, that all forces might be connected in some elegant way. Long before he had the tools to prove it, Faraday sensed that electricity, magnetism, and light were not separate phenomena, but expressions of a single underlying truth. This belief guided his entire career, and it was born not in a university or laboratory, but in the quiet reading room of a bookbinder's shop. Despite his growing reputation, Faraday remained humble and self-aware. He often wrote about his limited education, expressing gratitude for what little he had learned and for the chance to do meaningful work. He was not driven by money or fame, but by the sheer joy of discovery. Even when he became one of the most respected scientists in Britain, he continued to live simply, avoiding the social pretensions that surrounded many of his contemporaries. To him, science was not a career. It was a calling, a sacred duty to explore and explain the natural world for the benefit of all. His self-education journey was more than a personal triumph, it was a message to humanity. It proved that knowledge is not confined to the privileged. With curiosity, perseverance, and passion, even a poor apprentice could unlock the secrets of the universe. Faraday's rise from poverty to prominence shattered the rigid barriers of class and education that defined his time. He became an icon of intellectual democracy, a man who showed that greatness can emerge from the humblest beginnings. Faraday's story was not without struggle. There were moments of doubt, exhaustion, and loneliness. He faced condescension from the scientific elite, who viewed him as an outsider. But he never allowed bitterness to cloud his purpose. Instead, he turned every setback into motivation. His early hardships had taught him resilience, the ability to endure with patience and faith. He once said, "Nothing is too wonderful to be true if it be consistent with the laws of nature." That statement captured the essence of his spirit, optimistic, rational, and deeply curious. His journey also reflected the broader transformation of science during his lifetime. In the early 1800s, science was not yet a formal profession, it was a pursuit of gentlemen. Laboratories were rare, and experiments were often performed as demonstrations for amusement. Faraday's rise helped change that. Through his discipline and dedication, he helped professionalize experimental science, proving that careful observation and methodical experimentation could reveal universal truths. His background as a craftsman gave him an intuitive understanding of materials and instruments, which allowed him to design ingenious experiments that others could not imagine. His hands, trained in the art of bookbinding, became the tools of a pioneer who would bind together the forces of nature itself. Even in his youth, Faraday displayed qualities that defined his later greatness: precision, patience, and humility. He believed that science should never be about personal glory, but about uncovering truth. He once refused an offer to become president of the Royal Society, saying that such positions were for men of ambition. not for humble seekers of knowledge. His moral integrity was as remarkable as his intellect. In a world of vanity and rivalry, Faraday stood apart, modest, sincere, and guided by conscience. As the years passed, the once poor apprentice became a respected lecturer at the very institution where he had once been a servant. His lectures were not dry or academic. They were performances filled with wonder and clarity. People from all walks of life, nobles, children, and commoners, flocked to hear him speak. He had the rare gift of making complex ideas simple and beautiful. His Christmas lectures for young audiences became a beloved tradition, inspiring generations to see the beauty of science. In his voice, listeners heard not just knowledge but passion, the same passion that had driven a young bookbender to greatness. Faraday's humble beginnings never left him. He often spoke fondly of his childhood and of his parents, acknowledging how their honesty and hard work had shaped his character. He never sought wealth. When offered a knighthood by Queen Victoria, he politely declined, preferring to remain plain Mr. Faraday. Even at the height of his fame, he lived in modest quarters within the royal institution, surrounded by his books, notebooks, and instruments, the companions of his lifelong journey of discovery. What is most striking about Faraday's early life is that every obstacle he faced became a lesson. Poverty taught him discipline. Lack of education taught him self-reliance. Social rejection taught him humility. Each hardship was a stepping stone toward his destiny. He believed that science was not about power, but about service to truth, to humanity, and to the divine order he sensed within nature. His faith, though quiet and personal, guided his ethics and gave him strength. He saw no conflict between religion and science. To him, both were paths toward understanding the same truth. By the time he reached his middle years, Faraday had transformed from a poor apprentice into a world-renowned scientist, yet his soul remained untouched by pride. He never forgot the young boy who had once stared at the pages of borrowed books, dreaming of a world beyond his reach, and perhaps that memory kept him human even as he unlocked powers that would electrify civilization itself. Faraday's self-education was not just the pursuit of knowledge, it was a journey of the spirit. It showed that curiosity, when guided by discipline and humility, can transcend all barriers. In the echo of his story lies an eternal message: genius is not born in privilege but in persistence. From the smoke-filled streets of London to the illuminated halls of science, Michael Faraday's path remains one of the most inspiring odysseys in human history, a story that reminds us that light can emerge even from the humblest flame. As Michael Faraday's journey continued, the foundations laid by his early self-education began to bear fruit in remarkable ways. The years he spent in quiet study and observation had prepared him for challenges far greater than any he had known before. Within the walls of the Royal Institution, surrounded by instruments, metals, and mysterious forces, he began to apply the lessons that life itself had taught him: patience, simplicity, and faith in the power of careful observation. His rise from a poor apprentice to a scientist of international renown was not the result of formal training, but of a relentless mind that refused to stop learning. Faraday's early days in the laboratory were filled with routine and repetition. Yet, unlike others who might have found such work dull, he approached every task as an opportunity to learn. He cleaned glass tubes, polished metal rods, and prepared chemical solutions with an almost sacred devotion. He watched how gases behaved, how metals reacted, how light refracted, and slowly, he began to see patterns hidden beneath nature's surface. His hands-on understanding of the materials around him gave him a kind of intuition that no textbook could provide. Science was not abstract to him. It was alive, tangible, and full of character. Every spark and every drop of liquid spoke a language that he was learning to understand. Over time, Faraday's skill became impossible to overlook. Sir Humphry Davy, once his mentor, began to recognize the depth of his assistant's insight, though with a growing unease. There came a time when Faraday's name began to appear on papers and reports alongside Davy's. marking the beginning of his own independent career. Yet, despite the fame that slowly gathered around him, Faraday remained as humble as the day he had entered the bookbender's shop. He had never forgotten that he was a student of nature, and nature demanded humility. His self-education had taught him that understanding was not a gift but a journey. He kept notebooks filled with meticulous details, sketches of apparatus, notes on results, reflections on failures. These journals, now historical treasures, show the workings of a mind that learned not from lectures but from life. He treated every failed experiment as a lesson, every unexpected result as a clue. His curiosity was insatiable, but it was guided by discipline. He once wrote, "Work, finish, publish." To him, science was not about quick success, but about steady, honest progress, a philosophy born from years of self-taught perseverance. Faraday's real genius was his ability to see unity in diversity. While others saw electricity, magnetism, and chemistry as separate fields, he felt intuitively that they were connected. His early readings had inspired him to believe that nature was governed by simple, elegant principles. That belief became his compass as he began a new series of experiments that would define his career. Using coils of wire, magnets, and rotating disks, he searched for evidence that motion and magnetism could create electricity. The apparatus he built was crude by modern standards, yet guided by extraordinary insight. One day in 1831, after countless attempts, he observed a small but unmistakable spark, the birth of electromagnetic induction. In that moment, he had turned mechanical motion into electricity. It was a quiet experiment, performed without grandeur, but its impact would echo through centuries. The world would never be the same. From that spark came the principle that powers every electric generator and transformer today. But perhaps more profoundly, it proved that Faraday's lifelong self-education, his learning through observation and persistence, could achieve what even the most educated minds of Europe had failed to do. Yet Faraday's reaction to success was not pride but wonder. He marveled at the beauty of the discovery more than its utility. While others dreamed of profit, he dreamed of understanding. He saw himself as a messenger of nature, not its master. To him, knowledge was a sacred trust, something to be used for good, not greed. His modesty astonished those around him. When politicians and industrialists offered him wealth and titles, he declined. He preferred simplicity, choosing instead to continue his quiet research. His laboratory remained his temple, and his experiments were acts of devotion. The self-taught boy from the streets of London had now become the man who gave light to the modern world. Yet, in the midst of his triumphs, Faraday never stopped learning. His mind remained open, his curiosity undimmed. He continued to read, to question, to refine. His education was a lifelong process, a continuous dialogue with nature. In his later notebooks, he wrote of the importance of mental discipline, the art of training one's thoughts to see clearly and to think honestly. This discipline, he believed, was more important than any degree or title. Faraday's humility also made him a great teacher. He wanted others to share in the wonder of discovery. His public lectures became famous not for their complexity, but for their clarity. He had a rare ability to explain the invisible in ways that felt alive and real. Children and adults alike would sit spellbound as he demonstrated the mysteries of electricity with simple tools, magnets, coils, and sparks. He turned science into a language of light and motion, one that everyone could understand. His Christmas lectures, started in 1825, became an annual tradition that still continues at the Royal Institution today. In his voice, people heard not arrogance, but awe. Through these lectures, Faraday transformed public perception of science. He made it accessible, human, and beautiful. In a time when many saw science as cold and mechanical, he revealed its poetry, the invisible harmony of the universe. His own life was the perfect illustration of that harmony. The same discipline that had guided his hands as a book-bender now guided his experiments as a scientist. The same hunger that once led him to borrow books now drove him to explore the frontiers of knowledge. Every step of his journey echoed the same truth: learning never ends. Faraday's story also carried a deeper lesson about the nature of genius. It showed that intelligence alone is not enough. Genius, in his case, was a marriage of curiosity and character. He was not only a thinker but a listener to nature's whispers. He did not force conclusions, but allowed them to emerge through patient observation. His honesty in recording results, even when they contradicted his expectations, made him a model of scientific integrity. In a sense, his greatest education came not from books, but from his own honesty and humility. Despite his growing fame, Faraday faced personal challenges that tested his spirit. His health began to decline, and years of intense labor took their toll on his body and mind. There were periods when his memory faltered, and he had to step back from his experiments. Yet, even in those times, he remained grateful. He once said that to have lived and worked with nature was a privilege beyond measure. He did not fear the fading of his powers. He saw it as part of the same natural order he had spent his life studying. Faraday's faith, deeply rooted in the Sandemanian Christian tradition, gave him peace. His beliefs were simple but profound: to be honest, humble, and useful. He saw science as a form of worship, a way to understand the mind of the Creator. But unlike many of his time, he never allowed faith to distort his observations. He believed that truth, wherever it was found, was divine. His religion and his science were not enemies but companions. This harmony gave him strength and serenity, even when the world around him changed. As he grew older, Faraday became a symbol of integrity in science. Younger scientists looked up to him not just for his discoveries, but for his example. He had shown that greatness could come from modesty, that clarity was more valuable than complexity, and that knowledge must serve humanity. His home was simple, his habits unassuming, his heart sincere. When offered burial in Westminster Abbey, he chose instead a quiet grave beside his wife Sarah at Highgate Cemetery. He lived as he had always lived, humbly, faithfully, and with purpose. In the final years of his life, when his memory began to fade, Faraday would often sit quietly, surrounded by his notes and instruments. The sparks and coils that had once filled the air with light now lay still, but their echoes filled the world outside. The electricity that powered lamps, the motors that turned wheels, and the communication lines that spanned continents, all bore the mark of his vision. The poor book-bender's apprentice had indeed electrified the modern world. What made Faraday's journey truly extraordinary was not just what he discovered, but how he discovered it. He was a product of self-education, of personal discipline and moral strength. His life proved that learning does not depend on wealth, privilege, or formal schooling. It depends on curiosity, the courage to ask questions, and the patience to seek answers. His example continues to inspire generations of dreamers, reminding them that knowledge belongs to everyone willing to pursue it with sincerity. In every experiment, Faraday's fingerprints reveal the spirit of a learner. He never considered himself a master, even when he stood at the pinnacle of scientific achievement. His notebooks end not with declarations, but with questions, evidence of a mind that never stopped wondering. To this day, his words resonate: "Nothing is too wonderful to be true, if it be consistent with the laws of nature." That sentence captures the soul of his education: open, hopeful, and unending. Faraday's legacy extends far beyond physics. His journey from poverty to prominence remains a symbol of human potential. In classrooms, laboratories, and homes across the world, his story is told not merely as history but as inspiration. He is proof that knowledge can rise from anywhere, that a curious heart can illuminate the darkest corners of ignorance. The lights of our cities, the devices in our hands, the hum of power that surrounds us, all are silent tributes to a man who once read by candlelight in a small bookshop, dreaming of the mysteries of the universe. His path reminds us that every learner begins with uncertainty, that every question is a step toward understanding. Michael Faraday's education never truly ended because learning, for him, was not a means to an end but a way of life. He had found in science what poets find in art, a mirror of the human spirit. Through his work, he taught the world not only how electricity flows, but how knowledge itself flows, from one mind to another, from one generation to the next, from the humble to the great. And so as his life drew to a close in 1867, Faraday left behind more than experiments or equations. He left behind a philosophy that true education is the freedom to wonder, the courage to explore, and the humility to accept nature's truth. He had started as a boy binding books for others to read, but ended as the man who wrote one of humanity's greatest chapters in the book of science. Even now, nearly 2 centuries later, when the lights flicker on in our homes, or the hum of a motor breaks the silence, we are living in the world that Michael Faraday imagined. His legacy is written not just in textbooks, but in the rhythm of civilization itself. His life stands as a beacon for all who dream beyond their circumstances, a reminder that the power of a curious mind, guided by honesty and purpose, can indeed change the world. In every wire that carries current, in every field that bends invisible lines of force, there is a trace of his vision, and in every heart that dares to learn, there is a spark of his spirit, the same spark that lit the first flame of the modern age. In the quiet heart of London, inside the Royal Institution's laboratory, the faint smell of oil, metal, and chemical fumes lingered in the air. The walls were lined with glass jars, copper wires, and strange contraptions that glimmered under the soft gaslight. It was the year 1831, and Michael Faraday, now a mature and dedicated scientist, stood alone before his experimental table. His hair had grown darker with years of concentration, and his eyes, always calm and thoughtful, now reflected the light of a mind on the brink of revelation. Around him lay coils of wire, magnets of varying shapes, and instruments that seemed to whisper of hidden forces. He was chasing something invisible, a connection between electricity and magnetism that the greatest thinkers of his time had sought but never found. Faraday was no longer the young apprentice who once read books in a book-binding shop. He had become a master craftsman of nature's secrets. Yet, even as his reputation grew, his heart remained humble, driven by curiosity rather than fame. He had already explored the wonders of electrochemistry, studied the behavior of gases, and investigated how electricity could pass through various substances. But now his attention turned toward one of the great questions of the age: could magnetism produce electricity? This question had haunted scientists for years. They already knew that electricity could produce magnetism. Oersted and Ampere had shown that an electric current could turn a piece of wire into a magnet. But the reverse, creating electricity from magnetism, remained unsolved. It was a mystery that seemed to defy reason. Many had tried, many had failed. Yet Faraday believed that nature never created one-sided truths. If electricity could create magnetism, then magnetism, he reasoned, must in turn be able to create electricity. Somewhere, hidden in the silence between these two forces, was a law waiting to be discovered. Faraday's approach was not that of a mathematician, but of an artist of experiment. He did not rely on equations or abstract symbols. His language was that of wires, rings, and motion. His intuition guided him where logic alone could not. In August 1831, after months of frustration, he built a simple device that would change the world. It consisted of 2 coils of wire wound around opposite sides of an iron ring. One coil was connected to a battery, and the other to a galvanometer, a device that could detect even the faintest electric current. When he connected the battery, the galvanometer's needle flicked, just for an instant, and then stopped. When he disconnected the battery, the needle flicked again in the opposite direction. At first glance, the effect was small, almost disappointing. The needle's movement was momentary, fleeting like a breath. But to Faraday, that tiny motion was everything. It meant that a changing magnetic field, not a constant one but a moving or varying one, could indeed create electricity. He had discovered electromagnetic induction, the principle that underlies every generator and transformer ever built. With that single flick of the needle, Faraday had bridged two of nature's most powerful forces. It was not a grand explosion or a blinding flash of light. It was a quiet, delicate moment. Yet in that silence, humanity took its first step into the electrical age. Faraday, standing alone in his laboratory, may not have realized the full extent of what he had done, but deep inside, he felt that he had touched something fundamental, a truth that would light the world. His discovery came not through luck but through relentless perseverance. He had repeated his experiments countless times, altering wires, coils, and magnets, observing every small detail, and trusting the subtle whispers of nature more than any theory. His notebooks from that year show pages filled with careful sketches, notes, and reflections. The handwriting is precise but modest, showing no trace of pride. He simply wrote, "Induced electricity." For him, the discovery was not a triumph to boast about, but a key to a deeper mystery. What made Faraday's induction experiment so revolutionary was not just the discovery itself, but the principle it revealed, that electricity and magnetism were not separate forces, but two expressions of a single, unified phenomenon. In modern terms, Faraday had uncovered the first hint of what would later be called the electromagnetic field, a concept that would reshape physics forever. But Faraday did not think in the abstract language of fields or vectors. To him, nature was full of invisible lines of force, living threads that connected everything. He could almost see them in his mind, bending and curving through space, dancing between magnets and wires. These lines of force became the foundation of his understanding, and later, James Clerk Maxwell would translate those visions into mathematical form, giving birth to modern electromagnetism. In 1832, Faraday expanded his experiments. He discovered that moving a magnet near a coil of wire could also induce a current. It didn't require a battery at all. This meant that electricity could be generated simply by motion, by mechanical work. That realization changed everything. It meant that energy could be transformed from one form to another, motion into electricity, electricity into magnetism, and back again. It was the dawn of the electric generator, and eventually of the modern world. But again, Faraday's reaction was not arrogance or self-congratulation. He worked quietly, refining his experiments, demonstrating them to colleagues, and writing his findings with meticulous care. When other scientists questioned his results, he did not argue. He simply invited them to see for themselves. His experiments spoke with clarity that words could not match, and indeed, one by one, his peers began to realize that something monumental had occurred. Faraday's laboratory, though modest, became a place of pilgrimage for those who wished to see the miracle of induction. Visitors described the experience with awe. They watched as Faraday waved a magnet through a coil, and the needle on a galvanometer sprang to life, as if responding to some invisible hand. It was as though he had learned to touch the unseen world, to summon invisible currents that could flow through metal and air alike. Faraday's work did not stop at induction. He explored the relationship between electric and magnetic forces in greater depth, discovering new laws that governed their interaction. He also found that electrical lines of force could penetrate all materials, though with varying strength, an idea that would later influence the development of field theory and even the study of light itself. Step by step, his vision of a connected universe grew clearer. What is remarkable about this period of Faraday's life is how his discovery was born not of privilege or access to vast resources, but of imagination and persistence. His instruments were simple, often built with his own hands. His laboratory was small, but his vision was limitless. Many of his contemporaries worked with complex mathematics and grand theories, but Faraday's gift was his clarity, the ability to see the whole picture through direct experience. He trusted his senses, his intuition, and above all, his belief that nature's truths were elegant and consistent. The discovery of electromagnetic induction did not merely revolutionize physics, it changed the course of human civilization. Within decades, engineers built on Faraday's principles to create dynamos, electric motors, and generators. Electricity, once a mysterious curiosity confined to laboratories, began to flow into cities, homes, and factories. The world entered a new era, an era of light, communication, and power. Yet few of those who flipped a switch or watched a light bulb glow ever realized that the moment it all began was in a small London laboratory, when a quiet man observed a needle flicker for just a second. Faraday himself cared little for fame or fortune. When wealthy industrialists offered to patent his discoveries, he refused. He believed that knowledge should be free for all, not bound by greed. He once said, "Nothing is too wonderful to be true," and he lived by that faith. To him, discovery was a gift, a dialogue with the universe that belonged to everyone. He could have become rich beyond measure, but he chose to remain a servant of science, content with modest pay and the joy of understanding. The discovery of induction was not an isolated event, but the culmination of a lifetime's learning. Every book he read as a young apprentice, every experiment he performed, every hour spent observing nature, all had led to this moment. His self-education had not just given him knowledge, it had given him the habits of thought that made discovery possible: patience, humility, and imagination. He did not arrive at his conclusions through chance, but through a deliberate process of curiosity, guided by experience and moral clarity. Even his faith played a role. Faraday believed that the universe was an expression of divine order. He saw God not as a supernatural force interfering with nature, but as the author of the laws themselves. Thus, when he uncovered a new law of electromagnetism, he felt not pride but gratitude. Gratitude for being allowed to glimpse a fragment of creation's design. To him, each discovery was an act of reverence. Outside his laboratory, the world was changing rapidly. The Industrial Revolution was transforming cities, and machines powered by steam filled the air with noise and smoke. But Faraday's discovery promised a cleaner, more elegant power: invisible currents that could move silently, lighting lamps and driving machines without fire or fuel. Though he lived to see only the earliest applications of his work, he could sense the possibilities. His lectures often hinted at a future where electricity would become the lifeblood of civilization. That future, as we now know, arrived. As he demonstrated his experiments to eager audiences, one could see in his eyes not the pride of a conqueror, but the joy of a teacher. He wanted the world to share in the wonder he felt, the awe of realizing that invisible forces danced all around us, waiting to be understood. In his hands, science was not just discovery, it was poetry, philosophy, and faith combined. Faraday's notebooks from this period show how tirelessly he worked, even when his health began to waver. There were times when his mind grew weary and his strength failed, but he pressed on, driven by a sense of purpose that no illness could extinguish. Every experiment, every observation added a new thread to the web of understanding he was weaving, a web that would connect humanity to the invisible powers of the universe. By the end of 1831, his experiments had confirmed beyond doubt the principle of electromagnetic induction. Yet, Faraday never claimed ownership of it in the way others might have. He saw himself not as a creator, but as a discoverer, someone who had merely uncovered what nature had always known. When asked later about his achievements, he smiled and said, "The greatest of all discoveries is that we can know nothing." It was his way of expressing humility before the vastness of truth. In that humility lay his greatness. The discovery of electromagnetic induction was not the victory of a genius over nature. It was the meeting of an honest mind with the silent wisdom of the universe. Faraday had listened, and nature had answered. Michael Faraday's discovery of electromagnetic induction did not simply stop at proving that motion and magnetism could generate current. It ignited a revolution that reshaped the scientific, industrial, and even philosophical understanding of energy. The second half of his journey, the deeper and more refined phase, was defined by tireless experimentation, quiet contemplation, and a relentless pursuit to reveal the hidden harmony that bound electricity and magnetism together. It was a period of meticulous refinement, where every experiment, carried both the excitement of discovery and the patience of deep thought. Faraday understood that true science required time, not just in hours spent in the laboratory, but in the evolution of an idea, growing slowly through observation, failure, and intuition. After the initial revelation of electromagnetic induction in 1831, Faraday did not rest. Instead, he set out to uncover every possible aspect of this mysterious relationship. He asked questions that few had even imagined. How exactly does motion within a magnetic field create electric flow? Could this process be reversed? Could electric currents themselves create magnetic movement? These were not mere technical queries, but profound reflections on the nature of energy itself. In those dimly lit laboratories of the Royal Institution, Faraday would spend hours wrapping coils, turning magnets, and sketching lines of force, as though he were tracing the invisible handwriting of the universe. Each experiment was a conversation between human curiosity and nature's silence, a dialogue that would eventually give birth to the technology of the modern age. One of his most remarkable insights came when he introduced the concept of the magnetic field, a term that would later become one of the most important in physics. Before Faraday, scientists often imagined forces as direct pulls or pushes between objects. But Faraday envisioned something far deeper. He saw space itself as alive with invisible lines of energy. To him, a magnet was not simply a solid piece of iron with poles. It was a source from which invisible threads, what he called lines of force, stretched and curved through the surrounding space. When a conductor like a coil or wire moved through these lines, an electric current was induced. This visualization was revolutionary, not only because it described what was happening, but because it redefined how scientists imagine nature. The invisible became thinkable, and through Faraday's imagination, the unseen architecture of energy began to take shape. Faraday's mind worked differently from many scientists of his time. He was not a mathematician, yet his intuition was so precise that his experimental results often anticipated equations that would later be derived by others. James Clerk Maxwell, decades later, would translate Faraday's lines of force into the language of mathematics, forming the famous Maxwell's equations, the very foundation of modern electromagnetism. But the seed of those equations, the visual poetry of fields in motion, was born in Faraday's imagination. He was not guided by numbers, but by visions, lines arching and weaving through space, carrying invisible currents that connected everything. As the 1830s and 1840s progressed, Faraday's experiments continued to illuminate new dimensions of electromagnetic behavior. He explored how magnetic fields interacted with different materials and discovered that certain substances could influence the behavior of light when placed within a magnetic field, a phenomenon now known as the Faraday effect. This remarkable experiment linked light and magnetism, showing for the first time that the forces of nature were not separate entities, but interconnected expressions of the same underlying reality. Faraday was, in essence, uncovering the unity of physical laws, a principle that would later inspire both Maxwell and Einstein in their own quests for universal harmony. His laboratory was a place of wonder but also of quiet solitude. Faraday was not motivated by wealth or ambition. His drive came from the sheer joy of understanding. He often wrote in his diary about the beauty of an experiment working as predicted, not because it brought recognition, but because it revealed something true about nature. His notebooks were filled not with abstract formulas, but with sketches, reflections, and careful observations. In his mind, science was not about conquering nature, but about listening to it. "Nothing is too wonderful to be true," he once said, and those words captured his faith in the universe's hidden order. Even though Faraday's discoveries were monumental, their real impact unfolded gradually. The generation of electricity through induction was still a laboratory curiosity in his lifetime, but the principles he revealed would soon give rise to the electric generators and transformers that power the modern world. It was as if Faraday had planted seeds in the soil of science that would only bloom after his time. When electricity began to light cities, power factories, and connect continents, the silent architect behind that transformation was the same man who once wound coils of wire by hand in a small London lab. But beyond the machinery, there was something almost spiritual in Faraday's understanding of the natural world. His deep Christian faith shaped his scientific philosophy. He believed that studying nature was a form of worship, an exploration of the divine order written into the fabric of creation. Unlike some scientists who saw faith and science in conflict, Faraday saw them as two reflections of the same truth. This gave him a calm confidence, a sense of purpose that carried him through moments of doubt or exhaustion. His experiments were never rushed, for he believed that truth would reveal itself only to those who observed with humility and patience. Faraday's lectures at the Royal Institution reflected this same mixture of science and wonder. When he demonstrated electromagnetic induction before an audience, it was not just an experiment, it was a revelation. With a few coils, magnets, and sparks, he showed that the invisible forces surrounding us could be tamed to produce motion, energy, and light. The audiences were awestruck, watching as he turned invisible magnetism into visible electricity. For them, it was a glimpse into the future, a future where invisible power would flow through cities, drive engines, and connect the world in ways that were unimaginable. In his later years, Faraday reflected on the long journey that had begun with a simple question: could electricity and magnetism be connected? That question, so humble in form, had expanded into an entire universe of discovery. Even as age and illness began to affect his memory, his curiosity never dimmed. He continued to correspond with younger scientists, encouraging them to pursue knowledge for its own sake. His letters reveal a man who found peace not in fame but in the pursuit of understanding, a man whose true wealth was his insight into the order of nature. The discovery of electromagnetic induction stands today as one of the defining moments in human progress. Every light that flickers, every motor that hums, every signal that travels through the air owes its existence to that quiet revelation in Faraday's lab. Yet, the story is not only about the invention of a physical process, it is also about the triumph of imagination over ignorance, of simplicity over arrogance, and of humility over pride. Faraday proved that one does not need privilege or formal education to change the world, only a relentless curiosity and the courage to follow where it leads. When historians speak of revolutions, they often mention wars, kings, and empires. But Faraday's revolution was silent, a spark of understanding that reshaped civilization without a single drop of blood. The magnetic lines he once imagined still encircle the Earth, flowing through every circuit, every transformer, and every device that powers modern life. In that sense, his discovery is not merely a chapter of scientific history, it is the heartbeat of the modern world. As he looked back upon his life, Faraday never claimed ownership of his discoveries. To him, he was only the messenger, the interpreter of nature's truths. In his humility lay his greatness. His discovery of electromagnetic induction was not the result of ambition, but of reverence, a desire to understand the order that governed creation. That is why his legacy endures, not only because he uncovered the forces that light our cities, but because he illuminated the very spirit of discovery itself. Michael Faraday's discovery of electromagnetic induction did more than electrify metal coils. It electrified the human imagination. It transformed the invisible into the imaginable, the theoretical into the practical, and the mysterious into the magnificent. It bridged the gap between curiosity and civilization, between the spark of a thought and the light of an entire world. Even today, when we flip a switch or charge a device, we echo the silent work of a man who, in the quiet of his laboratory, discovered how motion could become light, how magnetism could become energy, and how knowledge could become power. When Michael Faraday first discovered the connection between electricity and magnetism, he did not yet realize that his experiments would eventually give birth to the machines that would power the modern world. The story of the electric motor and generator. two inventions that turned invisible forces into the heartbeat of civilization, began not with blueprints or grand machinery, but with a man standing quietly in his laboratory, surrounded by coils of wire, glass jars, and a few magnets. In that stillness, Faraday listened to nature. He was not guided by wealth or ambition, but by the purest form of curiosity, a desire to understand how the universe worked, no matter how small the detail. What emerged from those humble beginnings was nothing less than the foundation of modern electrical engineering. In the early 1820s, electricity and magnetism were still considered separate mysteries. Scientists knew that lightning and static shocks were forms of electricity, and they knew that magnets could attract iron. But how, or even if, these two phenomena were related remained unknown. The Danish scientist Hans Christian Rasted had recently made a fascinating discovery. An electric current passing through a wire could cause a nearby compass needle to move. This meant that electricity could produce magnetism. When Faraday read of Rasted's results, his mind began to race with a profound question. If electricity could create magnetism, could magnetism also create electricity? To most scientists of the time, the idea seemed too uncertain to pursue. But Faraday was not most scientists. He had an intuitive sense that nature was symmetrical, that forces acted in harmony and not isolation. He believed that if one form of energy could give rise to another, then the reverse must also be possible. This conviction set him on a path that would consume years of his life, a path that would lead to the invention of both the electric motor and the generator. Faraday's first experiments began with a simple apparatus, a magnet, a wire, and a bowl of mercury. He placed a magnet upright in the mercury and suspended a wire so that it could move freely around it. When he connected the wire to a battery, something extraordinary happened. The wire began to rotate around the magnet in continuous motion. For the first time in human history, electrical energy had been converted into mechanical motion. It was a moment of pure revelation, the birth of the electric motor. Faraday must have watched the wire circle the magnet with a sense of wonder that few people in history ever experience. In that quiet motion lay the future, the principle that would one day drive the engines of industry, spin the wheels of transport, and bring power to cities across the world. The device was simple, almost childlike, but its implications were enormous. It proved that electricity could create movement, and movement could, in turn, perform work. The invisible forces he had once studied in silence were now alive, capable of motion and power. This experiment in 1821 was one of the most beautiful moments in scientific history. It was the first demonstration of electromagnetic rotation, the essential principle behind every electric motor in existence today. Though Faraday's early motor was crude and impractical for large-scale use, it was a masterpiece of imagination. It represented the leap from theory to application, from the invisible to the tangible. To Faraday, this was not merely an experiment. It was proof that nature's hidden laws could be made to move the physical world. But Faraday did not stop there. His mind immediately turned to the opposite question. If electricity could produce motion, could motion also produce electricity? This was the reverse principle, and it would lead to an even greater creation, the electric generator. The motor and the generator are like reflections of each other. One transforms electricity into motion, the other transforms motion into electricity. Together they would form the foundation of the modern technological world. In 1831, after years of meticulous work, Faraday finally succeeded in creating a device that demonstrated electromagnetic induction, the process of generating an electric current through motion in a magnetic field. He wound two coils of wire around opposite sides of an iron ring and connected one coil to a galvanometer, a device that could detect electric current. When he passed a current through the first coil, the needle on the galvanometer of the second coil moved briefly, then returned to zero. The observation was subtle but revolutionary. The current in the first coil had induced a current in the second, not because of direct contact, but because of a changing magnetic field between them. It was this realization that allowed Faraday to build the first electric generator. His early generator was beautifully simple. A copper disc rotated between the poles of a magnet. As the disc turned, an electric current was generated and flowed through the circuit. This was the first practical demonstration that mechanical energy could be converted into electrical energy. The principle of electromagnetic induction, born in Faraday's mind and proven in his laboratory, became the heartbeat of every power plant on Earth. Whether in massive hydroelectric dams or tiny bicycle dynamos, the same principle hums silently, a living echo of Faraday's discovery. In those moments, as the needle of the galvanometer flickered and the faint current flowed through his coils, Faraday had unknowingly set humanity on a new path. His inventions would eventually give birth to the power stations that light cities, the motors that drive industries, and the technologies that define civilization. Yet, during his lifetime, Faraday himself could not have imagined the vast reach of his work. He was driven not by thoughts of factories or profit, but by the joy of uncovering the laws of nature. He once said, "Nothing is too wonderful to be true if it be consistent with the laws of nature." And this faith guided every experiment he performed. The world of the 19th century was a world still lit by candles and powered by steam. The Industrial Revolution had filled cities with machines driven by coal and sweat. When Faraday discovered how to generate electricity through motion, he unknowingly offered humanity a cleaner, more powerful, and more efficient source of energy. But society was not yet ready to understand the full importance of his work. The principles were far ahead of their time, and it would take decades before engineers would develop practical applications for them. Still, Faraday's simple apparatuses, a disc, a coil, a magnet, contained within them the seeds of everything that would follow. Faraday's genius was not just in what he discovered, but in how he thought. He saw patterns and unity in what others considered separate phenomena. When he looked at the world, he did not see electricity, magnetism, and motion as different subjects. He saw them as different expressions of the same fundamental reality. His mind moved effortlessly between the abstract and the practical, between philosophy and experiment. This rare combination of imagination and rigor allowed him to bridge the gap between pure science and applied technology. The first electric motor he built, though primitive, embodied the same principle that would later drive locomotives, fans, electric cars, and countless other machines. His generator, likewise, became the ancestor of all modern dynamo systems, the engines of electricity that keep the world alive. Each invention began as a spark of thought, a fragile insight captured through patient experimentation. Faraday's instruments may have been simple, but his ideas were infinitely powerful. He often worked alone, surrounded by glass flasks, metal coils, and the soft hum of current. The Royal Institution, where he spent most of his life, was his sanctuary, a place where science and imagination could meet. Those who visited him there often found him absorbed in his work, hands stained with chemicals, eyes alight with curiosity. To the untrained observer it might have looked like chaos, but to Faraday every wire, every magnet, every spark told a story. Faraday's discoveries of electromagnetic rotation and induction marked two halves of a perfect circle, one creating motion from electricity, the other creating electricity from motion. This symmetry spoke to something deeper, something almost poetic, about the balance of nature's forces. Energy, he realized, was not created or destroyed, it merely transformed. Long before the formal laws of thermodynamics were articulated, Faraday sensed this eternal cycle, this elegant dance of power and motion. As the years passed, Faraday's reputation grew, but his humility never faded. He refused to patent his inventions, believing that scientific knowledge should belong to all humanity, not to individuals. His moral integrity was as inspiring as his intellect. When offered wealth or titles, he declined them, preferring a life of quiet study and service to knowledge. His refusal to commercialize his discoveries delayed their industrial adoption, but it also preserved the purity of his legacy. To Faraday, Science was a sacred duty, a way of understanding the divine craftsmanship of the universe. Each experiment he performed was a dialogue with nature, and nature always answered honestly. When his first motor spun in the mercury bath, it was not just a triumph of technique. It was nature speaking in motion, revealing her laws to a mind patient enough to listen. The faint movement of a wire around a magnet became a symbol of the hidden forces that govern existence. That simple rotation would one day become the spinning turbines of power plants, the whirring rotors of spacecraft, the tiny motors in every machine of the digital age. As the 1830s drew to a close, Faraday's work had already reshaped the scientific landscape. His discoveries had laid the foundation for entire industries that did not yet exist. But for him, the satisfaction was not in what society would gain, but in the beauty of the discovery itself. In one of his journals he wrote, "The beauty of electricity or of any other force is not that it is useful, but that it is beautiful." That statement captures the essence of Faraday's spirit, a man who saw art in science, poetry in physics, and grace in the movement of invisible forces. In the dim light of his laboratory, surrounded by instruments of glass and metal, Faraday may not have realized that he had just ignited a new age, but history would remember that moment, the spark that turned thought into power, and power into progress. His electric motor and generator were not merely inventions, they were revelations. They proved that humanity could harness nature's most mysterious forces, not through domination, but through understanding. And that understanding would light the world. Faraday's invention of the electric motor and generator was not the end of a journey. It was the birth of a new era. The silent motion of a wire spinning around a magnet had evolved into a principle that would eventually power the engines of the world. But the years that followed were not about fame or wealth for Faraday. They were about refinement, reflection, and the unfolding realization that his discoveries had touched something far greater than science alone. He had revealed a bridge between the physical and the invisible, a connection between the forces that moved the heavens and the ones that could now move the hands of humankind. In the decades after his first experiments, Faraday devoted himself to exploring every nuance of the relationship between motion, electricity, and magnetism. His laboratory became a universe of copper, iron, and glass, each object a vessel for discovery. He understood that nature's secrets were not revealed by chance, but by patience and humility. For Faraday, each experiment was an act of faith, faith that the universe operated according to laws that could be discovered through careful observation and honesty of thought. His electric motor and generator were the proof of that faith, evidence that even the most mysterious forces could be understood if one simply asked the right question in the right way. Faraday's early motor, though primitive, became a symbol of what human ingenuity could become when guided by curiosity. He often demonstrated it at the Royal Institution, where audiences gasped as the wire spun endlessly around the magnet. In that moment, the audience was not merely witnessing an experiment. They were seeing motion born from the unseen, the transformation of invisible energy into life, like movement. Faraday's calm explanations made the extraordinary seem simple. He showed them that the laws of nature were not hidden behind magic, but open to all who dared to look closely. As the years passed, others began to build upon his work. Engineers, inventors, and scientists across Europe recognized that Faraday's principles could be expanded into machines of immense power. But for Faraday himself, the fascination lay not in the machines, but in the ideas behind them. He saw in the rotation of the motor and the induction of the generator a glimpse of the harmony that governed all energy. To him, the world was not a collection of separate parts, but a single, interconnected system, a great web of forces where everything influenced everything else. His mental picture of lines of force, weaving through space, was more than scientific, it was almost spiritual, a vision of unity within creation. Faraday's understanding of fields was decades ahead of his time. Most of his contemporaries saw electricity and magnetism as mechanical effects, as if forces were being pushed through invisible gears. But Faraday saw fields as living entities, dynamic and continuous, filling all of space. His visual imagination allowed him to perceive what others could not. When he looked at a magnet, he did not see a lump of metal, he saw a shimmering network of invisible currents extending outward, looping, bending, and vibrating through space. To him, these lines of force were the very language of nature. When motion disturbed them, electricity was born. When electricity flowed, motion followed. The motor and generator were not just inventions, they were manifestations of a universal rhythm. His experiments often appeared simple to outsiders: a few coils of wire, a turning disc, a magnet, and a needle twitching on a galvanometer. Yet, within those simple components lay the essence of modern civilization. Faraday had found the fundamental process by which nearly all electrical energy would ever be produced. When a turbine turns inside a dam, when a windmill spins on a distant hill, when the giant coils of a power plant rotate to feed the electric grid. It is Faraday's discovery in action. The entire infrastructure of modern life hums with the echoes of that quiet London laboratory. Every lamp that glows, every city that buzzes with power, is part of the legacy of that spinning copper disc between magnetic poles. But even as his discoveries spread across the world, Faraday remained deeply humble. He refused to accept a knighthood, declining all titles and honors that would separate him from his sense of simplicity. He lived modestly with his wife Sarah, who stood by him through all his long nights of experimentation. Their relationship was one of quiet devotion, grounded in shared faith and purpose. Faraday never sought recognition, his joy came from understanding the truth. In one of his writings, he said, "A man who is certain he is right is almost sure to be wrong." To Faraday, humility was not weakness. It was the gateway to discovery. As his fame grew, he was invited to advise on practical uses of his discoveries. Governments and industries sought his guidance, hoping to turn his principles into power systems and machines. Yet Faraday hesitated. He believed science should first seek knowledge, not profit. When the British government asked him to assist with chemical weapons during wartime, he declined, stating that science should be a force for enlightenment, not destruction. That moral clarity was one of the reasons he remained so deeply respected, even by those who could barely understand the depth of his genius. Faraday's lectures became legendary. Children, adults, and scholars alike would pack the Royal Institution to watch his demonstrations. During his famous Christmas lectures, he showed young audiences how magnets could make electricity and how electricity could make motion. His voice was calm and filled with wonder, his hands steady as he guided them through experiments that seemed almost magical. But to Faraday, there was no magic, only the beauty of law and order. He believed that the greatest gift science could offer humanity was not power or technology, but understanding. By the 1840s and 1850s, Faraday's work had become the cornerstone for a new generation of physicists. His concepts of magnetic and electric fields inspired James Clerk Maxwell, who would later translate them into mathematical form, creating the famous Maxwell's equations. These equations unified electricity, magnetism, and light into a single framework, confirming the very vision Faraday had seen through intuition. It was as though Faraday had sketched the melody, and Maxwell had written the score. Together, they gave birth to the entire field of electromagnetism, from radio to radar, from motors to microwaves. Faraday's health, however, began to decline in his later years. The strain of decades of experimentation and exposure to chemicals affected his memory and strength. Yet, even as his mind faltered, his spirit remained luminous. He would sit quietly by the window of his home, watching the light flicker, perhaps reflecting on the unseen forces that had shaped his life's work. In that fading light, there was symbolism. A man who had brought light to the world, now sitting in its gentle glow, at peace with the knowledge that his discoveries would continue long after him. The world, meanwhile, was beginning to catch up to his genius. Engineers built larger, more efficient dynamos based on his principles. The first power stations emerged, cities were lit by electric lamps, and transportation began to shift from steam to electricity. Every spinning motor, every humming generator was a living tribute to Faraday's vision. Though he never sought recognition, his name became synonymous with electricity itself. The unit of electrical capacitance, the farad, was named in his honor, a small but fitting reminder that his influence measured more than volts and amps. It measured the transformation of civilization. Faraday's inventions did not just change science, they changed how humanity perceived power. Before him, energy was seen as something external, fire, steam, muscle. After him, energy became something internal, flowing invisibly through wires, fields, and machines. The concept of power itself was redefined. Electricity became the lifeblood of modern society, pulsing through cities like veins through a living body. Faraday's motor and generator were not just tools. They were the organs of a new world. Even today, almost 2 centuries later, the principles Faraday uncovered remain untouched by time. The generators in power plants, the alternators in cars, the motors in appliances, all operate on the same laws he discovered in that modest laboratory. Technology has evolved, but the physics remains eternal. When engineers design new turbines or energy systems, they still follow the patterns Faraday revealed. His work did not merely contribute to science. It became science. What makes Faraday's story so profoundly human is that he began with nothing, no formal education, no wealth, no privilege. Yet, he became the architect of the electric age. His discoveries remind the world that genius is not born in universities or titles, but in curiosity and perseverance. He was a man who looked at a simple magnet and saw the future. In the final years of his life, Faraday withdrew from public duties, spending his time in quiet reflection. Visitors who met him during this period described him as gentle, wise. He died in 1867 at the age of 75, leaving behind no fortune, no factories, only the invisible legacy of the forces he had revealed. His grave was simple, in keeping with his life, but his influence reached beyond any monument. Today, the hum of every electric motor and the spark of every generator whisper his name. When a turbine spins or a light glows, the invisible currents that flow through our world carry a fragment of his spirit. Faraday's inventions did more than electrify the modern world. They electrified the human imagination. He transformed invisible forces into the engines of civilization, and in doing so, bridged the gap between mystery and mastery. Michael Faraday's electric motor and generator were more than scientific triumphs. They were symbols of humanity's eternal search for light in the darkness. They remind us that even the smallest spark of curiosity can ignite revolutions, that wonder is the true source of invention, and that the most powerful energy of all comes not from machines or magnets, but from the human mind that dares to dream. Michael Faraday's revolutionary work in electromagnetism and electrochemistry marked a turning point in human understanding of the natural world. It was not simply a matter of discovery. It was the revelation of an entire system that connected electricity, magnetism, and chemistry as one unified force. In an age when most people still saw these as mysterious, separate phenomena, Faraday envisioned an elegant harmony between them, a hidden order that governed the universe from the smallest particle to the vast movements of the cosmos. His experiments did not just illuminate science, they reshaped the very way humanity perceived energy itself. Faraday began his journey into electromagnetism with one profound question: could electricity create magnetism, and could magnetism in turn create electricity? This question was inspired by the earlier findings of Hans Christian Ørsted, who had shown that an electric current could deflect a magnetic needle. Faraday wanted to go deeper. He wanted to know if motion itself could be turned into electricity. His experiments were delicate and precise, built with little more than wire, magnets, and the keen insight of his imagination. When he moved a magnet through a coil of wire and saw the needle of his galvanometer flicker, he knew he had unlocked something fundamental. This was electromagnetic induction, the process by which motion through a magnetic field produces an electric current. That single experiment laid the foundation for nearly every form of electrical generation that exists today. Faraday's discovery of induction was not merely a scientific step, it was a leap into a new era. The spinning of turbines in power plants, the rotation of engines, the transfer of energy through transformers, all of these are descendants of Faraday's insight. What he uncovered was a universal principle that motion and magnetism could give birth to electricity, and that electricity could, in turn, produce motion. This symmetry fascinated him, and it became the centerpiece of his life's research. At the same time, Faraday was exploring another invisible world, the world of electrochemistry. In his small laboratory, he began experimenting with how electric currents could decompose chemical compounds, a process known as electrolysis. Through careful observation, he established the laws that now bear his name, Faraday's laws of electrolysis. These laws revealed that the amount of substance released during electrolysis was directly proportional to the amount of electric charge that passed through the electrolyte. It was an extraordinary realization, showing that electricity and chemical change were intimately linked, two sides of the same natural process. What made Faraday's approach so remarkable was his refusal to rely solely on mathematics. He trusted observation, visualization, and physical intuition. His mind worked like a lens, focusing the chaos of experimental data into clear patterns of understanding. He described electricity not as a flow of fluid, as many of his contemporaries believed, but as a manifestation of fields, continuous, invisible lines of force that filled all of space. This concept, revolutionary at the time, later inspired James Clerk Maxwell to formulate his electromagnetic equations, which remain the foundation of modern physics. In essence, Faraday's imagination reached beyond what his era's tools could measure. He could see the shape of the unseen. His experiments in electromagnetism were as elegant as they were profound. Using coils, magnets, and disks, he demonstrated how motion and magnetic fields interacted to produce continuous current. He also invented the Faraday cage, a device that could block external electric fields, proving that electric charge resided only on the surface of conductors. This discovery has become fundamental in modern electrical engineering, protecting everything from sensitive laboratory instruments to spacecraft from electrical interference. Faraday's discoveries in electrochemistry transformed industries. From refining metals to producing essential chemicals, his principles guided new methods of manufacturing that built the foundations of modern technology. But Faraday himself was not interested in wealth or fame. His satisfaction came from the pure joy of uncovering nature's secrets. He often said that science must serve truth, not personal gain. In his humility, he reminded the world that curiosity and integrity were worth more than any reward. Faraday's belief in the unity of natural forces led him to see electricity, magnetism, and chemistry not as isolated effects, but as expressions of a single divine order. His deep Christian faith shaped his scientific outlook. To him, uncovering the laws of nature was an act of reverence, a way of reading the handwriting of God in the fabric of the universe. When he described the beauty of magnetic fields or the elegance of electrochemical reactions, it was with the awe of a man who saw science and spirituality as reflections of one truth. The impact of his work can hardly be overstated. His theories and experiments bridged the gap between pure science and applied technology. Every electric motor, every generator, every battery and chemical process that powers modern life carries a trace of his insight. Even today, when physicists explore quantum fields or electrical engineers design microchips, they walk in the intellectual pathways Faraday first illuminated with his wire, his magnet, and his unshakable curiosity. Michael Faraday's work in electromagnetism and electrochemistry was more than a series of discoveries. It was a revelation of unity. He showed that the world operates not in fragments, but in harmony. Each force, each law, each phenomenon was part of a greater whole. Through the quiet precision of his experiments, Faraday helped humanity see that the universe itself is a vast web of connection, held together by invisible threads of energy. His legacy is not merely in machines or equations. It lives in the very light that powers our cities and the invisible currents that connect us all. Faraday's influence on future generations of scientists was profound and everlasting. He was not merely a discoverer of laws and forces. He was a teacher of vision, a guide for minds that would go on to define the very language of modern science. His work became the foundation upon which others built the architecture of electromagnetism, chemistry, and even quantum theory. What made his legacy so powerful was not just the discoveries themselves, but the way he thought. The purity of his reasoning, the honesty of his method, and the spiritual humility that guided his pursuit of truth. Through his ideas, Michael Faraday became a silent mentor to the greatest scientific minds of the centuries that followed. When Faraday passed away, he left behind no mathematical formulas, no thick volumes of equations. Yet, his conceptual imagination inspired James Clerk Maxwell to give mathematics a new soul. Maxwell took Faraday's idea of lines of force and turned them into a set of precise equations that unified electricity, magnetism, and light into one grand theory of electromagnetism. It was as if Faraday had drawn the first sketch of a hidden universe, and Maxwell painted it with mathematical color. Without Faraday's mental image of fields, Maxwell might never have seen that light itself was an electromagnetic wave. Thus, the light that shines from the stars and the radio signals that travel through the air are both echoes of Faraday's insight. Faraday's influence extended beyond Maxwell. Scientists like Heinrich Hertz, who demonstrated electromagnetic waves in space, and Guglielmo Marconi, who used them to invent wireless communication, were carrying forward the torch lit by Faraday's experiments. Every advance in electrical communication, from radio and television to radar and the internet, has its roots in Faraday's original vision of invisible forces interacting across space. His simple coils and magnets became the grandparents of satellites and smartphones. The entire electromagnetic age, which connects the modern world, was born from the mind of a man who once worked as a poor apprentice binding books. But Faraday's influence was not only technical, it was moral and philosophical. He changed the way scientists thought about science itself. In a time when many sought fame, wealth, or social standing through their work, Faraday pursued knowledge for its own sake. He believed that the true scientist must be humble before nature, seeking understanding rather than dominance. This quiet integrity inspired future generations to see science as a sacred trust, a duty to reveal truth, not to exploit it. Albert Einstein, who held Faraday in the highest regard, once said that Faraday's life proved how imagination and simplicity could uncover the deepest laws of the universe. Einstein often kept Faraday's portrait in his study, calling him one of the greatest experimental philosophers who ever lived. Faraday also redefined the relationship between theory and experiment. His approach was grounded in observation, but guided by intuition. He was not content to collect data. He wanted to understand the unity behind it. This mindset shaped the philosophy of physics for the next 2 centuries. Maxwell, Thomson's Lord Kelvin, Hertz, and later pioneers such as J.J. Thomson and Ernest Rutherford all worked in the light of Faraday's example. Even in the age of quantum mechanics, Faraday's belief in interconnected forces remains embedded in the way physicists think about fields, particles, and energy. The quantum field theories of today are, in essence, mathematical continuations of Faraday's original vision, that all matter and motion are governed by invisible fields that fill space. Beyond laboratories and equations, Faraday's impact reached education and public science. His famous Christmas lectures at the Royal Institution became a model for scientific communication. He believed that the wonders of nature should be shared with all, not hidden behind technical jargon. Through his demonstrations, children saw iron filings dance in magnetic patterns and sparks leap from coils. They learned that the universe was alive with forces waiting to be understood. His way of teaching, clear, passionate, and respectful, laid the groundwork for modern science outreach, where education is not about memorization, but about awakening curiosity. The legacy of those lectures continues to this day, broadcast every year, keeping his spirit alive. Faraday's influence also crossed disciplines. Chemists found inspiration in his precise measurements and electrochemical laws. Engineers drew from his principles to design motors, dynamos, and transformers. Physicists absorbed his field concepts to explain radiation and atomic structure. Even philosophers of science admired his method, which combined empiricism with vision. He showed that scientific creativity was not just about reason, but also about faith in the order of nature. His notebooks, filled with sketches and questions, became treasures for future thinkers, a record of a mind constantly asking, why and what if? What truly set Faraday apart was his moral strength in an age of industrial ambition. Despite the growing commercialization of science, he remained detached from profit. He rejected patents on his inventions and turned down opportunities for wealth. To him, knowledge belonged to everyone. This purity of purpose inspired the ethical ideals that shaped institutions of science worldwide. His example taught generations of scientists that the pursuit of knowledge was a service to humanity. When the British government offered him burial in Westminster Abbey among kings and statesmen, he declined, preferring a simple grave. Yet today, his name shines brighter than most who rest there. Faraday's influence continues to echo in modern science and technology. The principles that govern electric cars, renewable energy systems, communication satellites, and even quantum computers all trace their lineage to his discoveries. His understanding of induction underpins wind turbines. His vision of electromagnetic fields guides particle accelerators. His insights into electrochemistry power batteries and fuel cells. The digital age, where invisible energy moves information across the globe, is built upon Faraday's legacy. The world he imagined, where unseen forces could be harnessed for progress, has become our daily reality. And yet, perhaps the most profound legacy Faraday left was not material but spiritual. He demonstrated that genius and humility could coexist, that faith and reason could walk hand in hand. He once said, "Nothing is too wonderful to be true if it be consistent with the laws of nature." That belief became a guiding light for every scientist who followed, encouraging them to dream boldly yet remain grounded in truth. Faraday's influence endures not only in machines and theories, but in the very attitude of inquiry. The courage to question, the patience to observe, and the wonder to imagine. Through every discovery that expands human understanding, through every spark that lights the dark, Michael Faraday lives on. His influence is woven into the circuits of our world and the minds of those who continue to explore it. He was not only a man of science but a builder of the future, a visionary whose spirit electrified generations yet to come. Michael Faraday's character was as remarkable as his discoveries. He was not only a man of science but also a man of deep humility, unwavering faith, and moral strength. In an age when ambition and recognition often drove men of learning, Faraday stood apart, guided not by pride but by purpose. His life was a testament to simplicity and sincerity. Every experiment, every lecture, and every discovery reflected his integrity and devotion to truth. His character gave his science a soul. It transformed his work from mere investigation into a spiritual pursuit of understanding the divine order that governed the universe. Faraday was born into poverty and never forgot the struggles of his early life. Though he rose to become one of the most respected scientists in history, he never allowed fame to change his heart. He remained grounded, kind, and generous. His humility was legendary. Despite being offered a knighthood and burial in Westminster Abbey, he refused both honors, believing that such recognition belonged to kings and conquerors, not to a servant of science. He preferred to live quietly, surrounded by his books, instruments, and the calm companionship of his wife, Sarah. When people praised him for his genius, he would gently turn the conversation away, saying that all his discoveries were gifts of nature waiting to be revealed. Faraday's faith was central to his character. He belonged to a small Christian sect known as the Sandemanians, who valued simplicity, honesty, and humility. For him, science and religion were not in conflict, they were reflections of the same truth. Studying nature was, in his eyes, an act of worship. He often spoke of the unity of creation, seeing in every experiment a glimpse of the divine design. His faith gave him balance, it protected him from arrogance and despair. When asked how he reconciled his religious beliefs with his scientific work, he replied that he saw both as serving the same master, the creator of all things. In this way, Faraday's spirituality became the moral compass of his science. His discipline was equally inspiring. Faraday worked tirelessly, often from dawn until late into the night, repeating experiments dozens of times until he was certain of the result. His notebooks, thousands of pages filled with careful observations, show the precision and dedication with which he approached every problem. Yet, he never let ambition blind him. He once wrote, "Work, finish, publish." Those 3 words summarized his philosophy: do the work thoroughly, understand it completely, and share it honestly. This ethic of responsibility and transparency became a cornerstone of modern scientific practice. Faraday's humility also shone in his interactions with others. He treated everyone with respect, whether they were fellow scientists, students, or the janitors who cleaned his laboratory. He believed that knowledge should never create distance between people. During his lectures, he spoke in clear, simple language, ensuring that even children could understand the beauty of science. He would smile as sparks danced between electrodes or as magnetic fields made iron filings form graceful patterns. To Faraday, teaching was not a duty, it was a joy, a way to ignite the flame of curiosity in others. His kindness made him beloved by generations of students and colleagues. Despite his fame, Faraday lived modestly. He rejected offers of wealth and never patented his inventions. He believed that the discoveries of nature were not personal possessions, but universal gifts meant for the benefit of all. When industries began to profit from his principles of electromagnetic induction, Faraday never sought a share of the fortune. Instead, he took satisfaction in knowing that his work had helped humanity. In a letter to a friend, he once wrote, "I have no wish to be rich, I only wish to be right." Those words capture the essence of his soul, a man who valued truth above all material rewards. Faraday's humility was matched by his courage. He was unafraid to challenge established ideas or to admit when he was wrong. He had no pride in error and no shame in uncertainty. He believed that mistakes were the path to truth. This intellectual honesty made him one of the most trustworthy figures in the history of science. His peers often said that if Faraday claimed something to be true, it could be accepted without question. His reputation for honesty became a moral standard for all who followed in his footsteps. Even as age began to weaken his body and mind, Faraday's spirit remained bright. When his memory began to fail, he quietly withdrew from public life, refusing to let vanity overshadow dignity. He spent his final years in peace, surrounded by the natural world he had loved so deeply. Visitors often found him sitting by the window of his home, watching the play of light and shadow, as though contemplating the unseen forces that had shaped his life's work. When asked if he feared death, he replied gently, "I shall be with Christ, and that is enough." Those words revealed the serenity that came from a life lived in harmony with faith and purpose. Faraday's moral character influenced not only his contemporaries but generations of scientists after him. His humility reminded them that science was not about personal glory but about service to truth and humanity. His honesty became a model of integrity in research. His faith, though private, inspired many to see the pursuit of knowledge as a noble calling rather than a race for power. In an age where ambition often overshadows ethics, Faraday's life stands as a timeless reminder that greatness lies not only in discovery, but in character. Michael Faraday's legacy is not just in the electric currents that power the world, but in the moral current that runs through the heart of science itself. He showed that a true scientist must be as pure in intention as in intellect, as humble in spirit as he is bold in imagination. His life teaches that the light of knowledge shines brightest when guided by the virtues of humility, honesty, and faith. Faraday's strength was not only in his mind but in his soul, a soul that found beauty in truth, and truth in the quiet, invisible forces that bind the universe together. Michael Faraday's lasting legacy and impact on modern civilization extend far beyond the laboratory walls where his discoveries were first made. He was not simply the founder of electromagnetism or electrochemistry, he was the architect of a new world powered by invisible forces. His experiments in electricity and magnetism transformed the way humanity harnesses energy, giving birth to the electrical age that defines our daily lives. Every flicker of light, every hum of a motor, every transmission of power through a city's veins carries within it the echo of Faraday's genius. His ideas became the foundation stones of the modern world, shaping industries, communication, transportation, and even the philosophical understanding of nature itself. The electric motor and generator, both conceived through Faraday's insight into electromagnetic induction, revolutionized technology. Before his discoveries, energy was bound to visible, tangible sources like fire, water, and muscle. After Faraday, energy became invisible, flowing silently through copper wires and magnetic fields. His principle, that moving a conductor through a magnetic field creates an electric current, became the beating heart of civilization. Power stations, turbines, and transformers all operate on this same law. From the machinery of factories to the screens of smartphones, every spark of modern convenience can trace its origin to the humble coils and magnets that Faraday first assembled in his laboratory. Without him, there would be no electric age, no lights in our cities, no motors driving our progress. Yet Faraday's legacy reaches far deeper than technology. He changed the language of science itself. By introducing the concept of fields, continuous, invisible regions of influence surrounding electric and magnetic bodies, he gave humanity a new way to visualize the universe. Before him, scientists thought of forces as acting only through direct contact. Faraday's idea that space itself could carry energy was revolutionary. It paved the way for James Clerk Maxwell to describe electromagnetic waves mathematically, leading eventually to the discovery of radio, X-rays, and light as parts of the same spectrum. Today, when physicists speak of gravitational fields, quantum fields, or electromagnetic radiation, they are speaking in the language Faraday created. His field theory reshaped not just physics, but the entire scientific worldview. Faraday's legacy also lives in the moral and educational spirit he inspired. He proved that science could be both a practical tool and a noble pursuit. His life demonstrated that true progress comes from curiosity guided by ethics, not ambition. The institutions he strengthened, especially the Royal Institution in London, became models for public engagement with science. His Christmas lectures, designed to awaken wonder in children, continue more than a century and a half later, broadcast to audiences across the world. In every demonstration of electricity sparking through air or magnets dancing across iron filings, his voice still speaks, the voice of a man who believed knowledge should enlighten, not exclude. Modern technology owes its soul to Faraday's discoveries. The generation of electrical power, the operation of electric motors, the transmission of information through electromagnetic waves, all of these are his intellectual descendants. When cities come alive at night under electric lights, when trains move silently with magnetic propulsion, when computers process signals through fields of force, they are all manifestations of the same natural laws Faraday uncovered. His inventions gave humanity control over the unseen, allowing people to command forces once thought divine or mysterious. The world as we know it, illuminated, connected, and powered, is the ultimate tribute to his imagination. Faraday's influence extends even into modern scientific philosophy. He showed that great discoveries begin with simple questions and a clear vision of nature's unity. His insistence on careful observation, honest reporting, and moral integrity became the ethical foundation for modern research. He believed that science was a form of service, a way to benefit mankind by revealing the order hidden within chaos. Today, as scientists explore the mysteries of the universe, from subatomic particles to the cosmic web, they continue to follow Faraday's principle that truth is discovered through humility and perseverance. His name is spoken not only in textbooks but in laboratories, classrooms, and hearts of those who pursue understanding for its own sake. Even the modern quest for renewable energy is rooted in Faraday's work. Wind turbines and hydroelectric dams operate on the same electromagnetic principles he discovered. The world's shift toward cleaner energy sources continues to rely on Faraday's vision of motion converted into power. He never lived to see cities illuminated or power grids spanning continents, yet every rotation of a turbine and every surge of current is a continuation of his legacy. In a sense, Faraday's spirit lives within every electron that moves to bring light and life to our civilization. But perhaps the most profound part of his legacy lies in how he bridged the gap between science and humanity. He showed that knowledge could coexist with humility, that faith and reason could walk together without conflict. His life remains an example of balance between intellect and conscience, discovery and responsibility. He never sought to dominate nature, only to understand it. This respect for the natural world resonates deeply in an age where technology and ethics often struggle to align. Faraday's message endures that science, when guided by virtue, becomes not just a path to power, but a path to wisdom. Michael Faraday's impact cannot be measured by inventions alone. It lives in the power grids that connect continents, in the lights that pierce the darkness, in the communication signals that cross oceans, and in the minds of scientists who continue to dream beyond the visible. His legacy is the invisible framework of the modern world, the unseen network of energy and understanding that sustains human progress. From the smallest electrical impulse to the vast magnetic fields of galaxies, Faraday's vision of unity still echoes through creation. He began life as a poor bookbender's apprentice, and he ended as the man who electrified the world. His discoveries gave humanity control over one of nature's greatest forces, transforming civilization forever. But even more enduring than his inventions was his example, a life of honesty, humility, and endless curiosity. In every spark of electricity and every beam of light, Michael Faraday's spirit endures. He taught the world that the greatest power is not in the machines we build, but in the human mind that dares to explore the mysteries of the unseen.